Hi guys, it's Professor Stevens. I'm going to go over an example with you that is finding an area between two boundaries under the standard normal curve. And you can see I have the problem already here. Find the area of the shaded region. So this is a problem in which you would have been given this image here. And it says the graph depicts the standard normal distribution, which means that the mean is 0 and the standard deviation is 1. They're bone density scores, but they're standardized with a mean of 0 and a standard deviation of 1, which means that the bone density scores are actually z-scores. And we're going to approach this problem with 3 different solutions, and the first one is going to be using Excel. So you can see first of all that I put my objective into formal denotation, showing that I am finding a probability. Because I'm finding an area, that means I'm finding a probability. The probability of randomly selecting a bone density score between negative 0.93 and 1.29. I'm going to start with the approach of taking a bigger left-hand area and subtracting off a smaller left-hand area. Now the reason we're doing this is that using norm dot distribution in Excel, it gives you probabilities from the left, and you can only enter one boundary. So we're going to first find the probability of the entire region to the left of the greater z-score. So that will be from here over. So all of that, all the way to the left towards negative infinity. And then we will subtract off the part that we don't want as part of our final answer, which will be the smaller region to the left of the negative or the smaller z-score. So you can see there that the smaller, the little green region, or the left-hand tail, you can find that using norm dot distribution, and that gives us an area of 0.1762. And then the bigger blue area would be 0.9015. And then I have more of an illustration down here. You can see the area between would be equal to taking the larger area all the way to the left and subtracting from that the little tail. That leaves you the middle part. Okay, so I'm not going to actually do it in Excel, but you can see what you would do to get those answers. You just enter the codes there, norm dot distribution, and the boundary that you want the area to the left of, the mean of 0, the standard deviation of 1, and 1 for cumulative. All right, then the next type of solution that you could have, let's look at one with using Excel again. But this time I'm going to do a different approach. What I'm going to do is I'm going to consider the full area underneath the curve of 1, area of 1, and then I'm going to subtract from that the left-hand tail and the right-hand tail. So you can see that the left-hand tail, again, we get an area of 0.1762, and you can see that down here in my illustration. The left-hand area right here, smaller tail, the left tail, 0.1762, and then I want to subtract from that the right-hand tail, which would look like this. It's cut off a little bit for some reason. I don't think I can fix that, but if you can just picture it going farther to the right, there's a right tail shaded region that matches the part where you see the little red R. And that would be the probability of a z-score greater than positive 1.29. However, because our norm dot distribution function only gives you left-hand areas, we're going to use symmetry here. And I'll show you the next illustration. The next illustration, as you can see, I have taken this part, this picture up here, and I have flipped it over so that you can see if we had a negative 1.29 there, the area that's smaller or to the left of that boundary would be the same as this area over here to the right of positive. So we're going to use symmetry, and you can see what I've done here, the probability of z being less than negative 1.93. Of course, this has to be subtracted away from 1. So we're going to start with the total area of 1 and then subtract from that the left-hand area and the right-hand area, the tails. And so doing that, we get the same answer. And you can see here that I use the norm dot distribution function, but I use the negative version of 1.29 because I know by symmetry they're the same. All right, now there is one other way you could solve this using the z-tables. And again, we're doing total area of 1 minus the left tail and minus the right tail. And again, we would be using symmetry because in our negative z-table, because we only use the negative side, the negative z-table, you would have to do the same thing you do with the norm dot distribution function, flip this one over and use the negative boundary. And so looking those up in the table, we would find the same probabilities again, 0.1762 for the left tail, 0.0985 for the right tail. Subtracting both of those from 1, you get that same answer again. And that's how you find an area in between two boundaries.